approach, which has been there in archaeology for a long time. Next, please. Now, what is a quantitative approach? Quantitative approach relates to understanding patterns, and yesterday she was talking about. We all look for patterns in our data or information. A quantitative approach is to look at patterns through numerical summaries. Numerical summaries means statistics. That is as simple as that. So we need to summarize our data information in such a way, numerically, that we will be able to express the things in a short form. Suppose we have 10,000 antiquities or 10,000 sculptures somewhere. Describing each would require the next 100 years. But if you can summarize in some numerical quantities, some numbers, in such a way that once they are uttered, the other person understands what you are talking about. So this is essentially a quantitative approach, which is different than the old qualitative approach, which is more subjective. Qualitative approach is subjective. For example, if you go to older, I have put things on the screen so that you can read, but I am not going to read all that. If you look at the old reports particularly, or even the reports today, it's very sorry to see that many reports even today are subjective, because they say, okay, on a particular site we found some hand access, some cleavers were found, a few cleavers were found, which is meaningless data, because a few has no meaning. A few for me is 2, but for somebody maybe 100. So this kind of a qualitative approach stops somewhere, because the subjective element has come in. Whereas if we are trying to convert it into some quantities, some numerical terminologies, then they can be put across the persons. And this is essentially a task of archaeological science. My specialization is in archaeological science, both zoology as well as mathematics and statistics in archaeology. Actually, in the 1990, before that, I started seeing that there is no quantitative approach in Indian archaeology. And then I started looking for how it can be utilized, the quantitative methods which I have learned, how they can be utilized in archaeology. And so today what I am speaking from is the experience of using quantitative methods in archaeology, particularly my own old field, that is archaeozoology. So I have used them, but I am not giving examples from that field, but I will give some examples in the end. Instead of doing actual work here, I will give some examples how the quantitative approach can help more than what we think. Next, please. This is again a simple description of what we do. It goes beyond description. Quantification goes beyond description and categories. Now we are all accustomed to categories or typologies. We take tools, we take coins, we take artifacts, terracotta figurines, whatever, and we classify into certain objects which are predefined. So when we say bangle, we know what is a bangle. In this manner, we go on describing in the categories. But that again, the categories become subjective unless they are defined very well. Like earlier I was listening to Madhulika talking, and the whole idea of creating a database, a national database, and then make it available across the nation to anybody, is to provide them objective frame or specific frame for understanding what we found. So if we do not define it in the first place correctly, specifically, then all our things will go wrong. So the main task of science is to systematize and specify with definitions. So importance of definitions is there in science therefore. And how do we define our categories? How do we define our typologies? Then only we can proceed. But quantitative approach goes beyond that, so that we can have good explanations, inferences, and then the explanations. Again, if you remember, those archaeologists who are here, that in the archaeological syllabus you must have heard about, explaining the things is an important part of modern archaeology. It is not just describing. We need to explain why certain things are there. And for this, all that provenance and measurements and all that is because of that. Because finally we need to explain. When the database is ready with us, we have to explain certain things. search for the patterns in that database and explain it for something. So that task is done by quantitative approach, much better than simple qualitative approach. Next please. Now a little bit of historical summary of how science and quantification became important in archaeological research. We have three stages, actually three-stage development. There was a first stage which is given here. It was mostly before 1960s, roughly before 1960s, when there were just descriptions, most of them. Occasionally a scientist was consulted, but only for some occasional purposes and not a full-time engagement. Then the excavators approached the scientists or people who knew science after the excavation is over. So already things were there and then they started. It is like getting something and then asking, now tell me how to use this for quantitative approach. So that was the stage mostly before 1960s. At that time nobody had idea ever in the world, I am not talking of Indian archaeology alone, nobody had that idea that quantification is important. People thought that mathematics and statistics are not for archaeology. They are two different realms. Okay. Those who go to mathematics are something different. The archaeologists go down and dig, and both have no connection. But it was broken very fast in 1960s, mid 1960s, and then we came to the second stage of development. Next please. Second. So here something happened in this phase of 1960s to 70s that scientists and archaeologists got mixed together for good say collaborations, and then scientifically oriented archaeologists and there were archaeologically oriented scientists who were interested beyond their own sciences. Particularly this happened to mathematics. There are some French mathematicians, they were doing mathematics, good research in that, but then they got interested in archaeology of the past, and then they started thinking, can I use my mathematics thing into it? And this is how the progress happened in statistics, quantification, and other things. Then this third stage, I mark it, this is my arbitrary marking, is that Journal of Archaeological Science is a mark which recognized science as a part of archaeology. Because there was a very harsh reaction to science earlier. Many archaeologists thought this is something foolish. We don't need you, mathematics, statistics, we don't need you. But soon that reaction got over, and then Archaeological Science Journal, which is now the topmost journal in archaeological field, got established. So I think I consider this as the turning point in the three-stage process. And then onwards, we are only seeing the progress of quantification, systematization, defining things properly, correcting the terminologies, because we have hundreds of terminologies. If you go to the culture, then you will see so many such complex terminologies. If you go to see stone tools, bone tools, again hundreds of confusing terminologies do exist even today. So that stage was filtered out, saying that let us define first what a hand axe means, what a cleaver means, what something means. And then when you utter that word, everyone understands what is it. So this stage came, and then quantification was not used just for describing, but for giving explanations from archaeological point of view. Because all this is for archaeology. All mathematics quantification is not for their own field, but it is meant for providing a tool to get more and more better results and more inferences. Next please. Now something little complicated, but I thought I should talk about is because the kind of work we do of quantification or whatever it is essentially the product of these two philosophy of science tools which we use. Don't worry about the names. Some of you might have heard when you heard about new archaeology stage, that there is a HD model, hypothetico-deductive model, and there is a ISP model, inductive statistical probabilistic model. Now this is very important because these two processes lead us deduction and induction from data to generalization and generalizations to data. This is also going to happen to our this national database also, because we need to generalize from this data and then come back and check whether it is true or not. That is the purpose of it. So inductive statistical probabilistic model says that we use statistics as a method, and we use induction as the philosophical method, and we use probability as a means to express that whatever we are saying, we have certain confidence or we don't have certain confidence in talking about. So all that work we do, whatever I am going to describe you further, is based on these two philosophy of science models. Next please. Now what it contains, as I said, probabilistic model and statistical, it has serious considerations for sampling, which is still not so good in Indian archaeology. People do not describe what sample size is there. Okay? Now suppose I am working on a site and I find 3 NBP shirts, but out of what excavated from 20 trenches, and you find 20 shirts excavated from 1 trench, it has a difference. Because unless the sampling is not specified, what is the total universe, that means from which you collected and how much you are describing, then it becomes meaningless to do any inference, because then what comes is the sampling error, theoretical sampling error. Therefore sampling is the most essential part of quantitative approach. So there are many methods, I am not going to describe them here. There are many methods, all of them are useful, all of them have some problems, all of them have some strengths. So depending on the nature of your work, you are going to use the sampling techniques. But sampling is essential to be described. How much is so important. How much you study and how much you are describing and how much you are confident about what you are saying. This is an essential part of sampling strategies. Since I am not teaching here, I am just giving you overview of what is quantitative approach. So we will not discuss anything about that right now. Next one please. Now again something basic. We have been discussing this database and discussing various fields since morning or yesterday also. This is essentially all the play of variables, understanding variables. A variable is a quantity which varies against constants. Like in mathematics, physics, we have constants. Here there are no constants, we have variables. Like shape is a variable, shape or the diameter of a say pot or anything for that matter is a variable. So these variables, we must understand which variables we are trying to look at, because each variable will require a different treatment further. And the major problem will come if you do not understand what type of variable we are handling. You cannot use appropriate methods for analyzing them. So there are various ways of defining variables. One is independent and one is dependent. When I come to the example which I have given for modeling, you will recall. Say if a site is situated at some position, somewhere on the geomorphic platform, which whatever local environmental conditions are, these are going to determine the place where site is going to be. So these variables are independent variables, and the location of a site is a dependent variable, because it is depending on certain factors or certain variables because of which you find a site there. So this is what is just simple explanation of dependent, independent variables. Then we have primary and derived. A primary variable is the one you measure. For example, I can see in the database.
Will you allow questions in between to your lecture, or later?
Better at the end, so that
okay,
once they have heard everything, they can ask any question. So when we say primary variable, it is something which you record yourself. For example, diameter of a bangle, which is primary because you have recorded it. Suppose you have recorded a thickness of also bangle, and suppose you have recorded something else as a measurement on that. Then if you can derive another variable, thickness divided by length or thickness divided by diameter, this will become a derived variable. Derived variables also have importance, and they are very helpful because they tell us relative to that. Suppose I have got bangles, I am going to give an example further. I have got bangles of small size to large size. Each will have different thickness, obviously, which will be dependent on the primary variable, that is diameter of the bangle. It can also depend on the manufacturing style or the need of the person. We don't know what people thought in earlier. Some people might have thinking that thicker bangle is better than the thinner bangle. We don't know. So not necessarily just on diameter, there may be some other variables which will come in picture. A derived variable can tell you this thing. I will come to that slightly later. Similarly, we have a third one called discrete variable and a continuous variable. Discrete variable means which can take only whole numbers, 1, 2, 3, 4, 5, as simple as that. Like people in this hall is a discrete variable. You cannot have 30.5 people here. You cannot have. You have 30 or 31. So the discrete variable, and why it is necessary to understand, because the value we are giving in the database, if it is a discrete variable, you cannot have a fraction. If a fraction comes, it's a mistake. It is wrong to put a fraction in the discrete variable, because then the handling of that discrete variable will be done differently. So continuous variables are like our measurements. We measure with a tape or vernier caliper. Yesterday I was hearing about vernier caliper, which has a least count better than the tape. So we use vernier caliper. So calipers can be used. Weights, we do weight of some object using a scale. This is a continuous variable because there the fraction is defined. 20.5 kilogram of fraction is defined. 0.5 kilo is a valid, theoretically valid value. Whereas in the discrete variable, half is not valid. So if you see sometimes the census reports, you may have seen some census reports, they say infant mortality rate 20 per 1000. They don't say 20 per 100 because then it will come to 0.2 something. So you cannot have 0.2 infants dying. That's why they are expressed in. So all we need to understand which quantity we are handling and what is the theoretically valid position in that. I hope this is adequate for the variables. Next one, please. Now, once we have data, there are many methods of handling the data. Handling the data is primary analysis and then secondary analysis, which is below. The primary analysis is to summarize. Again, I said the purpose of statistics and quantification is summarizing. So we need frequency tables. We create tables. And something which the art one has to learn in archaeology of creating tables, which I find very frustrating. People describing objects after objects, which can easily be converted into a small table. Easily convertible into small table. So that summarizing into frequencies is a very important thing, because then in a short span you can describe many things. Instead of describing every provenance, every object, everything one after another. Frequency tables are very useful. Again, you need to learn something about them, actually doing how to do it. But anyway, cumulative frequency is a very important thing which is generally not used by many people. Suppose you want to compare two things. I am giving some example next. Suppose you want to compare two sites, or say two trenches for that matter, and you have some data with frequency data. You can ask for cumulative frequency, which in one stroke you will understand, are they similar or not similar? Because these are all our questions all the time. When we excavate two sites, are they similar with respect to something? This is a common question. When we excavate different layers, whether layer this and layer that, are they similar to each other or not? For such answering such simple questions, cumulative frequency, which is also very simple to do, and with Excel it is actually very easy now. So you can use cumulative frequency. I am giving one example later. Then graphs, graphical methods. A lot of graphical methods are available, with each having strength, each having some problems also. But graphical method, graphs pick up, or the visuals pick up very fast the pattern which is expressed in tables. So human eye catches the graphs very fast, and one can understand easily without even describing anything. So graphical methods have to be utilized, which I find archaeological reports missing. Very rarely you see graphs, pie diagrams, bar charts, very rarely, which otherwise convey so much of information. Then there is something called outlier analysis. Outlier analysis is slightly complicated in the statistical stage, but simply it means finding out mistake or outlier. For example, suppose I am looking at say hand axis. A hand axis length is something like 150 mm or something normally. Somewhere I just find something which is 1500 mm. Somehow this is happening, this can happen. 1500 mm. So if I put in a graphical format, it will come as outlier, something there. Most of them are here and something is somewhere there. Now there are two possibilities. One is it's a simple mistake because we have learned counting very late in our evolutionary stage, not more than 5,000, 7,000 years ago. So we make mistakes while writing. Instead of writing 28, we write 82. This is a very common mistake which is done. Or instead of writing, when we write zeros, additional zero comes. This is also a common mistake human brain does. So instead of 150 mm, I write 1500 mm. And if I don't check it before next stage, it will continue. But sometimes the outliers may actually be reality. In some cases, they were manufacturing certain things in a certain range, but they also produce something which is very longer or bigger for some other purpose, or very smaller as say something symbolic, like some symbolic object to be kept with you. So instead of a functional one, you have something which is actually not outlier then in that case. So with judgment, you have to remove the outliers first, that means mistakes, eliminate out of it. And that's what I was mentioning while sitting there, that a software can easily eliminate outliers by providing a range, possible range. So somebody records a bead to be 5 centimeters, 20 centimeters, or 100 centimeters. The software can easily eliminate it as outlier. So that judgment has to be done. Anyway, data transformation is, I will skip it here because if the data is not of certain nature, you have to transform it into something for doing statistical work. There are log transformation, Z, Fourier, all that. Let's not go into it. Then we come to the secondary analysis. Secondary analysis is understanding relationships between variables. Suppose you have observed, as I said, length and width as the variables. Is there any relationship between them? Then primary analysis, after that you go for secondary. There are three types. One is called univariate. Uni means one, so one variable at a time. Bivariate, that means between two variables, relationship between two variables. And the third is multivariate, which relationships and understanding patterns using more than 2-3 variables. So there are different methods for that, and I'm giving some examples now. Next one, please. Now coming to what is called distributions, which we need to understand beforehand, is that when we look at our data, variables after putting them into graph or putting them into something, when we see that there could be a symmetrical distribution, like there is a center point, a mean value, which is normally called average in common terminology, but in statistics we use mean, not average. So if you are describing something in your reports, don't call it average. Average length of something is wrong, it is mean length of something. So this, at the center, then we have observations both on left hand side and right hand side, you can see on the top, symmetrically distributed, which means something. Ultimately our aim is looking at the behavior of the people. So they must have interacted with whatever they were doing with some ideas, and we are now trying to find out through some methods. So if we find a symmetrical distribution of this nature, left hand side and right hand side, mostly this will reveal that this is not a random process. This is not a random process. There is something which idea has gone in, and therefore they are producing in a certain range certain artifacts of different sizes. Then there are two other options. One is positive and one is negative. Skewed is a name used for skew. Positive skew and negative skew. If you look at this one, this side, you will see most of the observations which are in the left hand side of your curve. That means there is some tendency in your data where mostly they have selected one particular range more than the other range, and the reverse is for the other side. So they must have thought something to produce in a particular range. If I'm just talking of artifacts right now, So produce some artifacts in a certain zone of range, and a few also, but few. So this is exactly what inference you can draw just from drawing a curve. No complicated calculations, simple by looking at the curve. These are all called unimodal curves. Unimodal, uni means one. So there is one mode. If you look at the height of this, a peak is there, we call it a mode. So that means this curve, all these three curves are unimodal. There is only one point or around which most of the observations are there. A point around which most of the observations you are seeing it there. Next one please. Now there are other things called bimodal curve, and now here is one example, actual example, two actual examples of my work. Shell bangles, a simple thing. And what is simple? Shell bangle diameter is recorded, that's all. No complicated statistics yet done. Shell bangle diameter, and just classified and put it on the graph. And what, in this case, in early historic period, with my friend, we found there is not a single mode, there are two modes. You can see it here, two modes. That means there is one zone around which most of the observations are there. They were the smaller bangles, because left hand side is less, right hand side is large. Smaller bangles around which most of the observations fall, and then after some time again you see another peak which is larger bangles around which observations are there. Now we need to interpret, naturally we need to explain why this kind of behavior has found. Can we attempt here? Can we attempt?
We want to explain this.
Yes. Why it could happen?
Now you have given number, is y and diameter x. So if you go by that number and versus the diameter, so, but you have not given a year and all. So initially that number, more number, but the diameter also correspondingly increasing of the bangle as per your graph. Then if you go by diameter, diameter is increasing, then number also that decreasing actually. Whereas in B, that is that other one.
No, don't look at the other ones. There are 2 points.
Because the other mode.
Other mode.
Other mode. Other mode we can see is less than 50%.
No, why I am asking is, why it can happen? There are shell bangles. These are shell bangles.
Period you will not give.
No, it's not period, it's only one period. Just one period.
Manufacture problems. See, shell bangle, it involves so many technicalities.
Anybody else can attempt?
Children and adults.
Sorry?
Children and adults.
Children and adult could be one, yes. The bigger bangles are for bigger
For adults.
adults, the smaller ones for smaller young ones. This is one possibility. See, in explanations, quantitative approach, we need to eliminate the possibilities by rationalizing with some other data. And then eliminate, this is one possibility, obvious. What could be the other possibility? Anybody can think?
Atmosphere.
Sorry?
Atmosphere also one of the reasons.
No, there are bigger bangles, smaller bangles. From same context. Same context. Same period. Same cultural period.
There is a two different localities. We can take now.
It could be and
Yes, it can be. If there are 2 different localities within that, so we have to eliminate that possibility that we are combining all the bangles from one context. There could be that one locality has bigger bangles, another locality has smaller bangles. Obviously, that is true. There is third possibility.
thickness, other thickness,
No, we are not talking only one variable. We are talking only diameter. Nothing we have seen there,
There
etc.
are 2 more.
Okay, tell one.
Mean person and
Sorry?
Mean, according to the diameter of the arm size, mean person and thin person and
Yes. Something like children and adults, something similar. Adults only, but some with.
having this thing as
True, that's possible.
one is 2 sources of procurement. One means 2 different.
Yes, it could be. Now why I am asking these questions, and because we just cannot be happy with one variable.
One species,
Yes.
particularly from Gujarat coast, may produce small diameters of shells.
Perfect, perfect.
And from Tamil Nadu coast will produce another kind of
Yes,
diameter
yes.
of shells.
So we just cannot be happy with one variable. We have to look at some other variables like material, source of provenance, something else, thickness maybe, something else. But still one more possibility is
Another
there.
possibility is there.
Is there?
Another possibility is there.
Can anyone think of? Quickly, otherwise I will be running out of time. The another possibility is the larger ones are not actually bangles, they are armlets. And this possibility we found out correct because of ethnographic work. So when ethnographic work was conducted in that area, we actually found these two, one woman wearing both bangles and armlets, and they matched this pattern. So this is how simple graphical method has asked us to, or compelled us to ask 10 questions and then eliminate the possibilities. This is the beauty of quantitative approach. Unless you do that, you cannot think of such explanations. Okay. So anyway, that's second. Next one, please. Now coming to the three modes. This is also actual archaeological example from my own work at a site called Damdama in Uttar Pradesh, a Mesolithic site. I'm sure you have heard of, most of you have heard about it. This is, I looked at bird utilization because I said my own field is archaeozoology actually. Bird utilization pattern. So I looked at the bird utilization pattern from layer 1, that means to the top layer. Layer 1 to top layer. So on this side is layer and on the other side is relative frequency, because it is not absolute number but a relative number which I needed. So there are three modes, three peaks. Birds utilized by the Mesolithic hunter-gatherers of Damdama. It increased, reached a peak, it decreased, reached almost zero. Again after some time, because one layer is corresponding to chronology. Layers are chronological, all of us know that basic. So again it increased, again it decreased, again it increased, again decreased, 3 times. There are 3 peaks, that's why it's a trimodal curve. 3 modes are there. Again, explanation, we need, what could be the explanations? I'll just leave 1 or 2 minutes because quickly, anybody can attempt why you could have 3 peaks in utilization pattern.
Climatic conditions, climatic conditions, availability of the climatic conditions, some birds will exaggerate there.
Now see, these hunter-gatherers, Mesolithic hunter-gatherers were on a horseshoe lake, occupied the same position. So the birds coming there are also same. Seasonal occupation is not valid here. So that means they hunted the birds, utilized them for some time, more and more and more, and then they stopped.
There are other things.
So what is the possibility? One is simply that the birds in that area
got
exhausted, started becoming extinct, and again the bird fauna regenerated, and then they started using it again. That is one thing. Or it could be a special choice also.
Exactly.
That means they understood that we cannot exhaust the fauna, so they deliberately could have reduced the hunting strategies, even though the birds are available, to allow them to regenerate. Now, all the possibilities and the explanations have to be tested with other archaeological data. This data alone cannot tell you. But again, this question is to be settled by looking at the other archaeological features, intensity of occupation, what are the other artifacts which are found in corresponding layers, and so on and so forth. But here I am talking about 3 modes compelled you to think. That is what my point is. I am not going into the archaeological explanations right now. Next one, please. Now this is 3 modes. There could be many modes also, which is called multimodal. Suppose you have chronological data, you can have 3, 4, more than 3 modes, 4 modes, 5 modes. It is quite possible. Then you need explanations for that. Now coming to univariate analysis, what is important is, again I am not going to give everything. There are 3 ways of explaining what is called central tendency, and means what is the center of my data, what is at my center. One is called mean, another is called mode, which we discussed just now, and the third is called median. There are methods which are based on all the three categories, and you require to do it. Then when we look at the variability, there is something which is variable. There is a mean and around which the observations vary. So there are different ways of explaining. One is skewness, which I already explained to you. Another is range, which we commonly know. Maximum, minimum is a range. Then we have coefficient of variation, which is a more advanced technique than these two, which allows you to understand what is the nature of variability. Then there are certain methods of comparing. For example, as I said, we are interested not in just correcting the numbers. Just numbers don't mean anything. We have to find out something and ask questions. For example, the first one is comparing one standard, one particular set of work with a standard known in the field. Just now listen to it, example I am taking. The second is comparing two different independent populations or two different samples. Say me one from one locality, another from another locality, one from one site, another from another site, one from lowermost there, another from topmost there. Any two independent samples comparing, there is a method available for that, to do that. And then comparing more than two samples, there are two methods available. One is Kruskal-Wallis, which formula is very horrible looking, but it is very simple method to actually to work on. And then analysis of variance, which is much complicated. There are two varieties. I am just putting them so that if any one of you is writing down, if you want to actually do the work, you can go to the books and do this kind of work. That's why I am putting the names, although it will require to discuss each 1 hour for one way, two way, all that. Anyway, so now we will see some examples. Next one, please. No, first I will explain the bivariate also and then go to the examples. A bivariate analysis is discussing two or more than two variables actually. Two variables in which we handle one, say length, another width or something. There are two methods. One is called chi-square, 2 by 2 chi-square method, which is a very simple one. And I advise that all of you who want to do research in this manner, should go for chi-square technique, which is simple, but is a very powerful, very robust technique, which can give you a lot of information, which is not just simply found. And please remember, I have never uttered a word percentage in my discussion right now. I have never talked about percentages, which is the most common mistake which is done in many fields, is comparing percentages. Percentages are not for comparison, because percentage have different theoretical basis. If you compare, I have got 10% black and red wear and 20% black and red wear there, which is meaningless theoretically. You will have to use chi-square technique for that.
What is the difference between the 2 into 2 and a square?
2 and 2 and?
2 and a x square.
No, it is not x square, it is chi-square. It's a Greek letter chi.
Huh?
It is a Greek letter
called chi. Greek letter called chi. That's the name of the method, chi-square. And the other extension is, instead of 2, suppose we have more than 2 categories. Suppose we have what, say, see sitting there, suppose 3 types of coins, material, gold, silver or protein or something, and the dynasty who has issued it. There are 4 kings maybe in one dynasty who have issued the coins successively. So we have 4 and 3. So there 2 by 2 chi-square will not help. Then you have to go for what is called R by C contingency table. R is row, C is columns. And then some calculation and some test, and it will give you confidently to say the inference, which is not possible in percentages. Never ever use percentages. It is the first lesson for statistics students. Percentages are not good, although they are very commonly used and mistakenly done. Then there are some other variables like Spearman ranks, Pearson's R, regression analysis, path analysis. Path analysis is something which very commonly is not done but can be done. Is suppose you have 20 variables for your object, then all of them may not be useful for doing something good further. So you eliminate some unimportant ones and arrive at certain variables which are more important than the others. This is a technique called path analysis which chooses the important variables among the non-important ones. I cannot give example right now. Now let us go next. Now coming to the examples, there are two actual examples. There is a site called Tumchetalapalli in Andhra Pradesh. I don't know whether it is now in Telangana, I have not checked, but anyway, Tumchetalapalli. So there were hand axes from two sides. One is this Tumchetalapalli and another is Narayana Delhi. Hand axe length is measured. It's a univariate analysis I am explaining to you for showing graphical techniques. This kind of a graph is a line diagram below. The other is bar diagram. Both are useful. Both convey very quickly what is the situation there. So just giving examples for that matter. Then these are the frequency tables that we compute the frequency and then go further. Next one please. This is an example of a pie diagram which very commonly we see in news also. BJP this many, Congress this many in a pie diagram. The similar technique. Pie diagram is a very powerful means of communicating because human eye catches very quickly the slices and the relative sizes of these slices. This is a pie diagram on that. Below is a cumulative frequency graph. Cumulative frequency graph is a simple technique after coming from frequency to compare two or more than two populations or two units. So here you can see the two sides being compared by cumulative frequency, and as you can see yourself visually that both are very similar. That means both have very similar behavior of hand axe production in certain range. These two, Chetanapalli and Narayana Delhi. Next one please. Now this is coming to the comparing things which I said before. One sample, that means your work done by somebody, some professor XYZ has found this mean length, some earlier, XYZ I am saying because not to name anybody, has found the hand axis to be 145 mm mean value. In those days they were giving averages. Okay. Now we have done this work, now which I showed you the graphs, which we have done the work now. Now can we compare that as a known value with what we found? Is it same? Is it not same? Is it more? Is it less than what that professor found earlier? For this we use what is called one sample t-test. Again, don't bother about looking at formula and other things. It is very easy to learn once you have to do it. So this is what is called one sample t-test, which gives you confidence. Confidence is saying that from Narayana Delhi, the hand axes were larger or smaller or similar. So this kind of simple inferences from one simple measuring one variable can be done. Next one please. And as I decided to give you examples just to see two samples. Now we have done this work from two sides, Narayana Delhi and Tumchetalapalli. We can compare these two as two independent samples with another test called t-test again, two samples test. Formulae are there, complicated formulae are there. There is a method of doing this testing. There is a standard of how to arrive at conclusion, and then we conclude that whether they are same or not same. Let's go ahead because I have lost a lot of time. This is Kruskal-Wallis comparing more than two samples, which is very simple in a way, which is robust. It is called non-parametric test. It is robust. It doesn't require a lot of assumptions. What we need to only use in a particular manner. Now here there is a river core thickness which was measured as a variable, and then from Godavari Valley, from Punjab and Gujarat, the core thickness has been obtained, and then we want to compare, find out whether the core thickness is similar in three localities, found from Punjab, found from Godavari, found from Gujarat. Are they similar? These are the questions we always ask. Are they similar? If they are not similar, why they are not similar is a further story. But we have to first prove that they are similar or not similar to each other. And then Kruskal-Wallis test does it very quickly. I will come to that point after. I thought I am telling now, later on. Next one please. This is how the test is performed. There is a confidence level at which level you are saying my inference is correct. 1%, 5%, 6%, 10%. And then you say this is what I am concluding with confidence of 1%. So there is a probability that 99 times out of 100, what I am saying is right. This is what is a probabilistic model which I spoke before. Next one, please. Now coming to more than two variables, which is essential for understanding relationship between more than two variables, and ultimately if you have heard modeling and other things further. Modeling is a very important thing to be done in archaeology. There are very few examples, but ultimately one can go to modeling, starting with bivariate relationships. Here I will explain you the data. This data is from Solapur district excavation or exploration of my student. Simple exploration data. What was there? The location of the site is there. You can see. Can you read from there? Difficult. I will read for you. First column is location. Second column is distance from the river. And the third column is size of the site in hectares measured. And then the fourth is thickness of the deposit. Thickness of the deposit. So how much meter of thickness of deposit has been found. So there are 4 variables with which the data is done. There were 10 sites and this data is plotted. Now once we go for bivariate, that means any 2 variables we talk, we can have 3 types of relationships. You can't see from there, right? People cannot see there. The first one, left hand side and the right hand side, they are 2 opposite of each other. The left hand side is that when one variable increases, the other variable decreases. This one. This is increasing, the other is decreasing. Whereas here one is increasing, the other is also increasing. This is one kind, 2 different opposite relationships. And the third is points scattered everywhere. Again, a graph is telling you this. Points scattered everywhere, that means there is no fixed relationship between the variable you are handling, first and second. Now, in this case, first variable was taken was distance from river. Distance from river, because we thought this is an independent variable. And then the second is the size of the settlement. So, is distance from the river controlling what size of the settlement could be? These are all possible because we don't know what behavior they did. We want to take out the pattern of it. So once they were plotted, what you can see is, yourself can see the actual work there down. What is the relationship? What is the relationship? Which is not expected actually in the model. What relationship is there? The blue dots.
When the distance from the river increases, the settlement size
is also increasing. Now why is a different story? We have to go into some other things. But distance from the river is increasing, the size of the settlement is increasing. Why? Because there could be some other factor. We are only looking at 2 variables.
Yeah.
There could be some other factor. There may be some other controlling factor which is governing why the settlement should increase. You understand this? Bivariate is only 2 variables at a time. But we have to begin with bivariate only when we have many variables. Next one please. Now this is actually the next stage of regression and modeling. If you want to go for modeling, that means I want to model why settlements are there in certain place. I want to model it, why they are there, which are the factors which are responsible for that. So I will have to start with what is called regression analysis, which is already done here. The graphs are there, you can see. The first one is the size of the settlement. SZ is size of the settlement, and the DT is the distance from historical trade route. So in Solapur district, we also monitored where was the trade route going and then where are the settlements. So then a relationship is found which is on top. Again, as you go from, as the size of the settlement is increasing, the distance from trade route is also increasing. Again, very complex thing to explain, but we'll have to explain somehow, archaeologically. You can see the other one, which is opposite relationship. When we have size of the settlement, there is some mistake in that. Distance from the river, which is actually, it is opposite that we have seen. So, like we are looking at so many variables, one by one, and then we can go for what is called modeling. Modeling is a very, very complex task, which is not done generally in the beginning stage. We have to handle so much of information numerically and then arrive at models. But we can go for ultimately, our idea is to explain why things are there. Next one, please. Now coming to multivariate, but before that I will talk a little bit about modeling. Modeling, and there is something called simulation. You have heard this word? Simulation, not stimulation, but simulation. Simulation is creating artificial situations like we are creating in computer games, artificial situations, and then you play with the game, with these situations, and think what is the best for that. There are a couple of modeling and simulations done. One is for Neolithic farmers, growing settlements in Europe. One published work is there. Another is the collapse of Maya civilization, which people have simulated. What could be the artificial situations created with, of course, computers, and then see which is matching to actual Maya collapse data. Similarly, for Roman forts in Europe, the growth of Roman forts and growth, and this how the Roman forts started increasing in the size as well as numbers. Some modeling and simulation has been done. This is a published work. In Indian archaeology, we are far away from this because our information is not. I am hoping once this data is there, temples and artifacts, national data, I can extract it and do some simulation. I don't know whether it will happen soon, but we need large level, high quality, authentic data for arriving at modeling and simulation exercises. Anyway, I began a long time ago with the simulation with Chalcolithic settlements in northern Maharashtra. I passed one stage, came to the next stage of writing programs, and then I got deviated into something else. So it is half done, my work on how Chalcolithic farmers utilize their areas around them. Next one is this. No, just is this where multivariate analysis. I am giving some examples. This is the data given by my colleague, Professor Kazade, of rice grains. So he has measured 3 primary variables, L, W and T, length, width, thickness, and the other 2 are the derived variables. That's why I said I will talk about derived ones. So he has got now 5 variables with us. Left hand side is sample number, specimen number, right hand side is the variables. Now I am explaining you one technique, multivariate technique, which is most robust, easy to work on, is what is called principal component analysis. Next one, please. It is called principal component analysis. This is an example. Now, the data came from 2 cultural horizons, Neolithic as well as Chalcolithic. This data. Now, you yourself can see most of the Chalcolithic and the Neolithic are separated from each other in a graphical format. Doesn't stop there, it's only for visual I am giving, that we can find Chalcolithic and Neolithic grains, rice grains, falling in different zones. And then when we further can investigate and confirm it, but that is the second and third round of PC analysis. I am just giving you one visual to see this one. Next one, please. Now I am giving you another example, another method, which is called discriminant function analysis, which is a very robust, interesting method, but not used quite often in archaeology. This is a very important work, and maybe some of you can use it further for variety of purposes. One is discriminating between objects. The meaning is discriminating between objects. As you can see, the green and the maroon bars are almost separated from each other. So this discriminant function method is actually segregating Chalcolithic grains and Neolithic grains. Do you understand what I am saying? So if there are some ambiguities in your data, you do not know where to put what, you can use discriminant analysis and get a confirmed one. Of course, it requires standards. Standard is built in this. So you know, for example, certain diameter of a pot is known to you, then you can discriminate this pot from other pots, actual objects. This is one of the methods which I have used. This is not statistical method. This is a mathematical method. And then softwares are available for that. What we need is to understand why we are doing it. Software can do it for you within a fraction of a second. That's not a big problem now. But why we want to do? If you want to segregate the things, again it can be used for outlier analysis also. If you put things into discriminant function analysis, outliers which are wrong, mistakes, can easily be found out separate from the main data. So this way you can also use it for ambiguous cases, for classifying things. So there is a method called discriminant classifier where you can classify your objects based on numerical data. Next one please. Another example of multivariate analysis to give you how it can be useful is by Professor Mohanty, my colleague, who has given me iron tools data. Some variables are measured, some variables are derived, and then we have got 23 rows, that means 23 megalithic objects, iron objects, and 7 variables coming from 4 sites: Bhagimari, Khairwada, Raipur and Gurgaon in Vidarbha region. This is his data. Next one please. Now this is a principal component analysis, which is a further step to that. Not just seeing visually, but trying to find out the clusters. All you can see is most of the sites in that polygon, most of the tools are falling in one zone in a polygon, and some others are falling away. Can you see yourself? Some points which are falling away. For example, M5, M14 from Maurjari are far away from the main cluster. Now why they are far away is a further archaeological question. But this technique is telling the archaeologists to see, look at your artifact again, why this one from Maurjari 2 are falling away from the main cluster. What is the reason? There could be a variety of reasons. They may be manufactured somewhere else, their size may be different, their purpose may be different, although they are similar megalithic tools, their purpose may be different. The question is open. But a simple technique comparatively, I am saying comparatively, a simple technique of PCA has put the archaeologists to ask more questions: why a cluster is there and why some are falling away. Okay. Next one please. Now next step to that is what is called cluster analysis. There are several methods, some assumptions, but that one has to learn. If you want to really do it, you have to learn the techniques. Cluster analysis tells you who is close to whom. I have run the same material from Dr. Mohanty's work. Which object is similar to which object from 4 different sites. Can you imagine what are the implications of finding this? We expect one site to have similar objects, obviously. But if we find similar objects from 2 different sites, then again the set of questions emerges. Is it that at one site the production was done and then used at another site? Is it that at third place they were manufactured and provided to 2 other sites? All possibilities one has to look at. But this cluster analysis will tell who is close to objects I am talking. Which object is similar to which object? Based on what? The variables that we have recorded. Obviously, this is based on the variables that we have recorded. And this is no subjectivity into it. I am not saying they are similar. My work is saying they are similar numerically. Next one please. Now third, multivariate analysis. I am just trying to show you that where it can be used in what kind of data. Professor Gopte was my senior colleague in Deccan College. He retired now, chemist, archaeological chemist. He has studied glass samples from historic sites all over India. Again, very similar to what Mohanty sir has done it. So glass samples from various sites were analyzed chemically for various variables. So many variables, like 10 variables and 28 glass samples he has studied. Now let's see what multivariate analysis is telling us. Next one. Next one, these are how the tables are constructed. Next one. This is a graphical explanation of what we find. Again, we can find here clusters, 2 zones, the artifacts categorized into 2 zones, and some artifacts still remaining outside the zones. When I looked back to his data, I asked him what are the sites, which are the objects from which sites. It showed that The top portion, the top one. This one came from the Central Indian province. This top cluster came from Central Indian province, somewhere in Vidarbha, and the lower one came from perhaps South India, perhaps Tamil Nadu, because he has studied provenances of these also. So probably we have got glass samples manufactured at two locations, at least two locations. The work is showing 2 locations and then spread to different sites or different objects. And but still, some remained outside. Those top ones, you can see these 2 triangles on the right hand corner. They are not falling in any of the things. Those 2, Dr. Gokte confirmed that they have come from outside of India. So this glass has come from outside of India, perhaps from Southeast Asia. Now, this he asked the question after the analysis was done, because just now they are just samples, they are looking just glass samples. They won't show to naked eye anything. So once this analysis was done, then they looked at the samples back and then they found the provenance that yes, this is coming from Southeast Asia. Comparatively simple technique. Again, I am using the word comparatively because some basic statistical understanding has to be done while learning this thing. Next one, please. Now, these are some of the books where you can consult. But before that, about multivariate analysis and about some misnomers or some misunderstandings that all of us archaeologists have are that we are doing temple work, we are doing iconography, we are doing numismatics. How can these techniques be utilized? I am sure he will support me that numismatics, a lot of quantitative techniques are being used. But in iconography, temples, how can we use these techniques? He said, okay, for you they are okay, mathematics, statistics, all right. But for our work, they are not useful. But this is not the case. Therefore, I deliberately studied Surya images with my student, Surya images, iconographic work from sites in Maharashtra. So from different temples, I think 26 temples or something, I did not do the work, he did the work. And he got the iconographic data. Now, iconographic data is typically, all of us know that Surya has 4 hands, 6 hands, whatever. In the top hand, this is there, in the right hand, this is there, lower hand is something, something is Abhay Mudra, all these descriptive things. I converted it into usable data for multivariate analysis. Somewhere in some hand there is a full lotus, somewhere there is only half lotus, somewhere there is a khadga, somewhere there is a parshu, all types of variabilities you can know. I am not an iconographist. So then when this data was converted and I used it for quantitative analysis and principal component to begin with, we found 3 clusters. One cluster which was matching to the sites in central India, particularly Chhattisgarh. The Surya images, when they were inserted from Chhattisgarh, they matched, one cluster matched with Surya images, another cluster matched with Goa, Konkan region, and the third cluster was in central Maharashtra, which was showing mixed characters. So probably the carvers who carved this thing or whosoever was ordering them to carve had influence from Chhattisgarh, some had influence from southern Maharashtra, and in central Maharashtra they were mixed things. Now this is impossible to discern from just description. Just to put my point strongly of what is quantification, this is only possible if you quantify your data correctly and do the correct methods. Now this is not an end to the work. Please remember, a statistical work is not end in itself. It is only a guiding thing to ask more questions. So that was earlier phase when I said earlier, people used to go to statisticians, oh we have all the data, you do something now. Do some jugglery out of it, numbers out of it, and then give something. It is not so. It is that tools will give you what to ask. You have to seek the explanations. Statistician has no means of telling you the explanations. As a statistician, I will go only this is the first cluster, second and third. Now you interpret. So this is how quantification is so important in archaeology, but unfortunately we are lagging behind because most of our previous 2 generations, they were not happy with statistics in Indian archaeology, They thought this is something fancy. Some earlier one generation thought it's a magic tool. So they thought that every question, archaeological question, can be solved by statistics. It is not so. Statistics has its limitation because statistics was not created for archaeology. It was created for some other disciplines like physics and astronomy and other things. So we are using the techniques with us. So we have to use it cautiously, not as a magic tool for answer to everything, but rather a means to create new questions and new explanations. Thank you very much. I think I have talked about it. Now we can have questions. Can I just get water? Oh, it is here.
Sir,
Yes, please.
when you are telling about iron tools found at two different places, you use the expression similar. That would have gone from A to B or B to A, etc. But when coming to glass, you use that chemical analysis. So see, in the same way, for iron also, if the content is known,
Yes, of
whether
course.
it's allied or steel or
Yes, of course. I
that we
understand.
can easily say whether it was from A to B or B.
Yes, that's true. But this is not my work. It is somebody else has done that work. So somebody needs to do metallurgy also, as you were suggesting. Look at the composition of impurities and then arrive at this conclusion. But that work will only come if you have such thinking. That is what I am saying. These are actual examples. I have taken data from others. This is not my work. My work is in archaeology, which all the techniques I have used, mathematical techniques, their importance, their strengths, all that I have done. But I have deliberately not given you my examples because I will be biased with my own subject there.
BD Kosambi already has done.
For what?
For numismatics.
That's why I said numismatics people are doing. But D.D. Kosambi's days are now, when the techniques were available were much primitive. Now we have much advanced techniques in analytical techniques. Even not only this, people have used it in literature also for finding out the layers in writing. One such work has been done on Mahabharata text of using multivariate techniques for understanding which text was composed when among the 10 mandalas. So the method is very robust. Only you need to utilize it in the way you want to utilize it.
But that NASA software, the planetarium software used, can it be accepted by?
No. There is a lot of misconception about NASA planetary position software because although it is not my topic today, but since the question is asked, it does not go beyond 4,000 years before Christ. It is useless before that point. So if somebody is predicting planetary things at 10,000 BCE, which is wrong. I mean the software doesn't allow you to do it.
But Mahabharata says 3102 BC.
See, a lot of people use a lot of things. But unless they know what for it is used, it can be wrong. I have learned statistics, just not to boast, but to remember my guru. I have learned statistics from a very famous statistician called father of Indian statistics, Professor P.V. Sukhatme, who was a great statistician, Padma Vibhushan for his work. I have learned statistics from him and he used to tell me, look, numbers are numbers. Any number is number. But unless you know why the number has come to you in front of you, you cannot interpret properly. So think why this number is in front of you. If you have a number, you have methods, you will get something out. But one has to be cautious. That's what his words were, and I remembered it after 40 years. I remembered it after 40 years, so I thought I will say it. Any other question?
Sir, I have just
please.
one. In the context of this database, NMMA,
Yes.
which is NMMA is developing, with statistics or the talk that you give, it can be applied to data to when the data is there.
Yes.
So it can be used for more for interpretation. Now, in that context, do you have something in mind which you can suggest to them
Yes, yes, of course.
to incorporate
Yes, of
in their
course.
fields or variables which, when they are recording the data,
Yes.
they can take care of that so that it becomes more useful for scholars
Yes,
like
yes,
you
yes.
who are using the statistical methods to
Yes, yes.
interpret.
I got it.
Yeah, so
I got it. When I talked of variables, because our data is in different fields, some variables are descriptive in our database, and some variables are measurements which are provided. When we provide a measurement, the measurement has to be with the correct list count. Correct list count means if you are using a vernier caliper, it has to be something 0.01 or something in that manner. It cannot stop at the first point, because your vernier caliper is allowing you to record in two digits beyond the normal. If you are using some other technique, then obviously the list count will differ. So one has to standardize what list count we are utilizing and put zeros. She was also talking about here. Put zeros even if there is nothing, because null and zero has exactly two different meanings, as she said very rightly, because this ultimately software is going to analyze all this. So software will consider null as zero and you will have trouble, or zero as null and you will have trouble. So if there is nothing, you have to record, not leave it as blank. If it is a continuous variable or numerical variable, you have to record 0 or 0.1, 0.2, 0.5, whatever it is, in that manner. Then the discrete variables or descriptive variables, we have to record in such a manner that the software which is going to analyze it further will pick up this thing. Suppose there is even a small discrepancy in the description, it will not pick up. The software is not going to pick up what is. Therefore, enormous importance is there for standardizing things of how you write. Even you write BID. If you write B capital and rest small, or all small, or first small and all three capitals, all possibilities to exist. Software is not easily going to pick up what you want to pick up actually. So a lot of standardization in terminology, writing, recording, and first defining the categories. A BID means BID. A BID cannot be. I have seen a lot of mistakes which are being done because of not standardizing the things. Particularly this is there in wares, in our archaeological wares, red ware, black and red, red on black, whatever it is. All those problems do exist of defining the categories correctly. So once you record something as a red ware, this is permanent for all 10,000 more years that it is red ware, and if a mistake is committed at that recording itself, this will perpetuate all through. So that's why the database of this importance, national importance, and that's why I saw a lot of mistakes which are coming because of not standardizing the things. What response has to be given to a particular field has to be defined first within a frame of range. What we expect in a field, unless it is defined, you cannot expect the correct answer for that. Therefore, all that variability is going to come. That variability is not good. Otherwise, variability is good in data because then it tells you something else. But in this kind of work, variability is not good. So to avoid variability, this standard what each field is going to expect, whether it's a numeric field, whether it is continuous data, whether it is independent data, whether it is dependent variable, all has to be first fixed. So as I said, I was a programmer a long time ago. The first task is to define what type of a variable it is. Whether this is a descriptive variable, if it is numeric variable, again in numeric what kind of variable it is. So the work starts actually there. Defining the variables first, what we expect, then generate data, then generate tables and then analysis, as you said rightly. That's perfect. What I was thinking is, you understand that what methods and what can happen so that the mistakes at the data stage can be avoided. That's why I decided to describe it this manner. You are right, sir. Any other?
So I have just had an inquiry over it. I have seen two graphs of yours. when you have shown one is Neolithic and Chalcolithic phase, where there was two different colors were there. So you said that Neolithic phase it came. So the Neolithic phase at one particular point and then Chalcolithic at the other point. But there was a point where that you have a
yes,
like an both you are getting an amalgamation of that is one. And second, in one of the graphs, I've seen the clusters. You have one cluster, two clusters, and the second you said there are two points were there, and you said it is from outside Southeast Asia. But there were one more, like still was there, which was not able to. But obviously, but my point was with both these maps, how much we deviate. That is called SD. What is standard deviation from your report? When you have the variables, then there is always. If you,
yes.
I think I couldn't understand how much SDs are there, because that gives help us to understand how much the standard deviation are there in your samples. So just
okay, okay, right. Now these are two examples from two different people. What you are referring to. In the Neolithic, Chalcolithic, there are some cases which are in between. Yes, right. You are right. Perfect. Now, the next question has to be asked: why are they intermediate forms? That is a botanical question, not a statistical question. I am showing there are two categorizations, some are falling in between. Now this is a botanist to decide why it is like that. Similarly, there Dr. Bokte told me those two came from. Another point is from India only, but not from the two clusters. So there might be third cluster. I did not explain every part of every graph. But the standard deviations, obviously, without which you cannot proceed. They are there, but I cannot put so much of standard deviations on the screen. So I just showed you the final product. I have made some shortcuts of showing only the final one. But obviously that is there. But the importance of technique is it can separate out things for you to investigate further. That is the purpose of telling you. And the PCA is very simple now. There is a software called PAST. PAST. It's a very small one. It's very small software. You can go to the Google and get it. Very simple one. Not much assumptions required. And you can easily use it. It's free of cost. Very small one. It is less than 1 MB, I think. It's a very small multivariate statistical package which you can use. All of you can download. And if you want to do some work, you can do the work on that. Any other question of enough? Too much of heavy numbers. So many numbers. Okay, thank you very much.